Hey, what's going on, guys? Let's do this problem right here. The question is asking a hydraulic turbine generates electricity, water flows at 3.4 meter cube per second and 0.4 meter diameter, and the inlet has 80 meter higher than the outlet. The inlet is 80 meter higher than the outlet, and the frictionless head loss through the pipe is 6 meter, right? And the first question is asking determine the power that is transferred from the water. So let's see how we can calculate this one. So they are asking for this power transfer. So let's say this is the fluid, power of the fluid, and that's what we are going to calculate. So we can, if we can find a head change, HF, let's say head change of the fluid times the flow rate, volume flow rate that's provided, Q is equal to 3.4 meter cube per second. That one multiplied by gamma. So this is related to water, right? So water, gamma for water is going to be rho g. That is equal to 9.81 kilonewton per meter cube. So we have these two values right here, but we have to find out the head change. To find this one, I can use the Bernoulli's head equation. So let's put the head equation first. So we have P1 over rho g plus V1 square over 2g plus Z1 plus head gain, right? Whatever head gain they has. And then we have P2 over rho g plus V2 square over 2g plus Z2 plus head loss plus head change. So that's what we are going to calculate. So let's look at the pressure first. So this is, we treat this one as when they had say hydraulic turbine, we treat this one as atmospheric pressure. So P1 and P2 is going to be the same thing. We can cancel both of them. And the velocity, like this is going through a pipe like this, right? So the velocity, since water is incompressible, we know that velocity is going to be equal all the way, right? It's going to be equal. So we can cancel this velocity too. So now we have the equation, and also we don't have any head gain that's provided, so we can cancel that one too. Head loss is provided, that is frictionless head loss through the pipe is 6 meter, so we can note that one down. Head loss is equal to 6 meter. And C2, this distance, the C1 minus, if we consider this one C1, the height is given, that is 80 meter. So we know the difference is 80 meter, so that's not a problem. So let's rearrange this equation and find the HF. So we can this HF is equal to Z1 minus Z2 minus HL. So Z1 minus Z2 is going to be equal to 80 meter. So we can put 80 minus the head loss is 6. So that's going to give us 74 meter. So we have this head change. Now we can calculate this power, right? So let's calculate the power. So power is going to be equal to HF, that is 74 meter, multiplied by this Q right here, that is 3.4 meter square per meter cube per second, that's volume flow rate, multiplied by gamma, that is 9.81 kilonewton per meter cube for water. And if we cancel all the units and stuff like that, we will end up with kilonewton, newton meter, that's going to be kilowatts. So kilowatts, and if you calculate this one comes out to be 246.82 kilowatts. And that is the answer for the first question right here. So that's the power that's transformed from the water. And second question is asking if the turbine has 85% efficiency. So let's give this neta T. Since 85% we have to divide it by 100, that's going to give us 0.85. So that's going to be neta T, neta turbine 85. And that can be calculated by, so let's say W shaft, right? W shaft, that's we are trying to calculate. Shaft is equal to neta T times this one. If I multiply neta T by this one, that gives us the power generated by this one's, the shaft power developed by turbine, right? So we can multiply this one, it's 0.85 times 246.82, and that gives us 209.80 kilowatts. So we have this information right now, and that's answer for the second question. The third question is asking if the turbine drives an electric generator that has 93% efficiency. So let's say this is neta electricity, and they have given this is equal to 93%, right? So we can divide this one by 100, and that gives us 0.93. That's neta electricity, and determine the electrical power generated. So to calculate this one, so let's say this is W electrical. W electrical, that is equal to neta electricity multiplied by this one, W shaft. So that's going to give us this value. So if you notice that it's going to be the power is going to be reduced and reduced and reduced as it going through these things, right? So that's how it's going to be. And we have the neta electricity, that is 0.93 times power shaft, that is 209.80, and if you calculate this value, that gives us 195.114, and that is the answer for this question. I hope you guys liked this video. See you next time.